If f of x equals 3x minus 1 over 2x plus 3, what is f negative 1 of x, which means the inverse of x? That's what this refers to. What is the inverse? Now, if you remember, the key to an inverse is inverse means we need to switch x and y. And I taught you multiple ways of how to solve this. What I'm going to do here is first the algebra way. So this f of x represents our y here. So if I wanted to solve this algebraically, I would need to switch x and y. So I'd say x equals 3y minus 1 over 2y plus 3. Now, I'm for a second just going to put a star over here because we're going to come back to this in a little bit. I'll show you how you can graph this and know what the graph of the inverse should look like. But now, if I were going to solve this, the first thing I would do is I would want to get rid of the denominator. So just so we can come back to that later and not be distracted, I'm just going to come back, clone it, and I'll do it over here. And so we'll say here's the algebra way over on this side. This is the algebra. All right, so if I want to do the algebra, I come over here. After I switch x and y, I'm going to multiply by the denominator because I do not like fractions. I want to make this fraction disappear. And so these two will cancel each other out because they're both factors. And now I need to distribute. So 2y times x is 2xy. 3 times x is 3x. This equals 3y minus 1. Now the step where people get stuck is kind of here. They kind of think, what do I do now? We want to turn this back into a y equals equation. To do so, I got to have my y's on the same side. And I'm going to move, in this one step, I'm going to get rid of my 3x in the same process. So I'm going to subtract the 3y over. That will get the 3y over here. But in the process, I'm going to move the 3x to the left side. Okay, so basically what's happening are these two values are going to swap around, except for when you move the 3y over from being positive on the right, it's going to be negative on the left. Those will go away. Those will go away. So what do I now have? 2xy, instead of having positive 3y on the left, it'll be negative 3y. And then instead of having positive 3x on the left, I'm going to have a negative 3x on the right, minus 1. Now the next step is I'm going to GCF here. I shouldn't say greatest common factor because it's not necessarily the greatest common factor, but I'll put that just for now. Is we're going to find out that there's a y shared here. So I'm going to pull out the y. It's kind of like reverse distribution. If I divide out the y, this is left with 2x. This is left with the 3. Equals negative 3x minus 1. And our last step, to get y by itself, is I would divide by 2x minus 3 on both sides. Now this should be the inverse here. And so I'm going to come over here and say that the inverse, f negative 1 of x, would equal negative 3x minus 1. And this is over 2x minus 3. That's what I'm saying the inverse is going to be right there. Now let's walk through a couple checks that we can do. Remember how earlier I said I can show you this graphing? So I'm going to come back over here, and now I'm going to do graphing. So with the graph, how can I graph that? If I come over here, I'm going to go to New Document just to clear out everything else. If I wanted to know the inverse, what I can do is click in the white space, and then go Menu, Actions, Text. And you can do this on Desmos as well. What I type in is the equation, x equals 3y minus 1 over 2y plus 3. Anytime in our calculator, if you have a variable solved, you can use Menu, Actions, Text, and just type in the equation, and it should graph it just fine. So 3y minus 1 over 2y plus 3. Now, it won't graph it right away. You have to highlight it, hold down, and so you can move around the value. As soon as you touch an axis with it, it'll graph it. This is what our graph should look like. So that's the inverse right there. The calculator has graphed it for us. Now, we would check with the equations. The technique of those multiple choices, you just try all the equations to see which one matches up. Now, we're saying we got the answer, so let's just try our value that we just got right here. We're going to say we think the value is, it was a negative 3x. I don't know why my calculator's been doing this. Let's change this to a negative 3x. Let's try it one more time. Negative 3x, there it is. O minus 1 over 2x minus 3. And enter. Notice this graph is perfectly on top, so we did have the correct graph. So this way works. So we checked by graphing and now realize we just switched x and y, we graphed that, and you can just try process of elimination on a multiple choice test to see which equation works. There's now one more thing we could do. Now I'm going to graph the original here. Something else that could really help you is thinking on the lines that an inverse, you switch x and y. If I graph this original, 3x minus 1, and I put that over 2x plus 3, what we should know about every inverse is that you're switching the x's and y values. So if I switch my x's and y values here, and I'm going to show you this from notebook, it's going to be a little bit easier to see. So I'm going to paste that here. And so now I have this graph, and let me just mark this so we're not confused. This is referred to as F2 right now on this picture. This is F2. This equation I have in there as F1. So that's the F1. Okay, now if we're switching x and y, check this out. You see how on the red graph, there is a horizontal asymptote that's occurring right in here. It looks like it's between 1 and 2, which means at 1.5. Now, if we correctly found the inverse, then there should be, instead of a horizontal, since we switch all x's and y's, there should be a vertical at 1.5. If I draw a vertical asymptote and put it directly at 1.5, you should notice that these would be lined up. And it is, which means this inverse has a horizontal or a vertical asymptote that it cannot equal, that x cannot equal 1.5 or 3/2 if you want to write it as a fraction. That will be a domain restriction that would occur on this equation, that x could not equal 3/2. We just discovered that here. And just the same, how by going back to the original, you see how this has a vertical asymptote, and this vertical asymptote occurs at -1/2. That would mean that there would be a horizontal on the blue at -1/2. You see how that works? So this one's domain restriction here is that if we wanted to write it in, we would say that x cannot equal, you'd solve it because you're not allowed to divide by 0, -3/2. That would be this one's domain restriction, so that x could not equal on the red equation -3/2, which meant the y over here would not equal -3/2. And one more time over here, the y, remember, follow the rules. This is not Bobo, not Botan, but eats DC. This exponents are the same. You would have that there's a horizontal asymptote at y equals 3/2, or the graph does not equal 3/2. You can look at it that way, which means that's why the x over here could not equal 3/2. So that's 3 different ways. So by switching, you might be going, what are the 3 ways? There's algebra, there's the graphing, and then finally there was the switching from the asymptotes to the x's and y's.